Today is the 19th of October 2023, and I'd like to discuss with you how to draw diagrams to scale. Okay. Thank you to everyone who has been helping this platform, and thank you for everyone who have subscribed, okay, and watching our videos. Thank you very much. Please, if you haven't subscribed already, can you please subscribe, share, like, follow, etc. Okay. I will really appreciate that. In the comment section, I normally write, please follow my notes/script. Okay. So, for instance, if I wanted to say multiply and I said divide, okay, and you don't watch the notes, you wouldn't know that it's multiplication. Okay. So at times maths is a lot of words, a lot of things to say. So at times some of these things happen. Maybe I want to say a rectangle and I say a triangle, or vice versa. So I would advise you to follow the notes. Okay. If in that instance you heard a number or something different, go by the notes. Okay, because the notes are very accurate. Okay, I've looked at it over and over again. Okay, so I could use your help on that. Thank you very much. Now, beware of scammers. Okay. We all know they are there. Okay, even the scammers know they are there. They have made a professional business out of them. Just beware of them. Don't fall into their traps. Okay, as I'm saying it to you, I'm saying it to myself as well, because somebody can just put a message in your inbox and say that I'm so and so. How do you know? You don't know. They are claiming. You don't know them. You've not seen it. So you need to be unlike, I know who my neighbors are. Okay. I don't know everything about them, but I know that this person is here, this person is here. But on the internet, you don't know. It could have well be anybody claiming to be somebody. Okay, so you can't just take everything on the internet as it is. You just have to be on guard and make sure that you are avoiding scammers. Okay, thank you very much. Now, recap. Our last video, we look at how to find the volume of some shapes, okay, of some complex shapes, and we use what we already know to find what we've been asked to find, that is the volume. Okay, last lesson we only looked at volume. Okay. Refer to the last video, please. Just watch it. Okay, we did some interesting work. Okay, and I said to you in that video, don't be intimidated by looking at complex figures and saying that, oh, I only know how to find the volume of a cube or a cuboid, so I wouldn't attempt this. Okay, so please have a look. Okay, it will be helpful to your law. Our starter today is a reminder, and I would like you to put it on your flashcard. Okay, we've already done some work on cones. Okay, we've looked at surface area. We've done videos on surface area, but and I wanted to just give you the formula again of the surface area of a cone. Okay, so if you open the cone, it has the circular bits, and then it has the round part there. Okay, you can see the cone as in a funnel. Okay, and if you go and buy chips, at times your chips is put in a cone. Okay, the circular part and this part here. It's not exactly like a triangle, but it is in this form. This part is a bit circular. Okay, to get it all round. Okay, so now to find the surface area of a cone, assuming it's a closed cone. Okay, now you need the area of the top, and which is a circular bit, and the all round area of the round, the thing that wraps around the whole circle. Now, because it's not like a full triangle, this is where the slanted heights come in. This is the slanted height. Okay, if it's a rectangle, then if it's a triangle, okay, then your perpendicular height will be from here to somewhere there. Okay, but if you draw a perpendicular height from this tip to there, it's not going to make right angles. So here you need your slanted height. Okay, so first you need to find the area of the top. Okay, which is pi r squared, which is the same as the circle. And then this length is your circumference. Okay, because you wrap it all around the cone, which is 2 pi r, and your slanted height, which is L, which is the area of this whole thing here. Okay, so now to find the surface area is A1 here, the area of the circle bit, and the area of this shape here, A2. So A1 is pi r squared, A2 is half, the base is the circumference, times the L, the slanted height. Okay, remember, you need the slanted height for the cone if you are finding the surface area. So if you find this part is half, circumference is 2 pi r, L is your slanted height, the height from here to there. So now your surface area A1 plus A2 will be pi r squared, which is the circle base, and pi r L, because if these two cancels out these two, then you have pi r L. Okay, now you can bring pi r out, okay, and have r plus L, which is the radius of the circle on top plus the slanted height, and then you multiply by pi r. Okay, but you can also leave it in this form depending on which one is easy for you to learn. So please add this to your flashcard, okay? And when we start solving questions, we will use it when you need it, or when you need to start solving questions at school or anywhere. You can easily use it. So boldly highlight it and write it out on your flashcard. So this is the formula for the surface area, okay, of the cone. Now, today we want to just have a simple lesson, I hope. Most of the diagrams that I've used to explain so far, most of them okay, thank you. Most of them are not to scale, okay. I've drawn them, they are not to scale. But today we want to look at how we can draw diagrams to scale, okay. There are times in real situations scale diagrams have to be used. You can't just do things without using a scale, okay. So for instance, if you are planning to build a property in an area, for instance, you have a big acre of land, you can't just go and be building anyhow, okay. You have to put a scale on it, plan such that you can make good use of the land, okay. So that is where scale come in. Building of schools and malls, you need to do it to scale, okay. When the architects are drawing these things and planning, they need to draw things to scale, okay. They can't just draw it anyhow. They have to use a form of a scale. Now, if you are building a car, a manufacturing company, or any other manufacturers, most of the things they do, motorcycles, machines, factories, they do it to scale, okay. Cars, they can't just build a big engine bigger than the car, okay. So maybe if they have a car a certain length, they need the engine or the containers a certain length, so that they can get everything in the car where it's supposed to, so that it can work properly, okay. Mapping, if you are using a mapping, especially a map in a book, how far, so you can't draw the whole of the UK or Europe on a very big map. You have to use a scale to scale it down, but you have to say that this is the scale that I'm using, okay. So for instance, if we are told that the scale used for a property or a shopping center is 1 centimeter to 100 meters, okay, then it means 2 centimeter will be 200 meters, 3 centimeter will be 300 meters. So 20 centimeters will be 20 times 100, which is 2,000 meters. So in actuality, you'll be seeing 20 centimeters on paper, but actually in real life it is 2,000 meters, okay. That is a lot of a thing you should think about, okay. That's why when I draw a diagram, I tell you it's not to scale. Okay, but we need to look at this morning, because at times you might be asked to draw things to scale. So for instance, if you have a trailer, okay, if the scale of a trailer is 1 centimeter to 120 centimeters, then if you have a 7 centimeter trailer, then it's 7 times 120 centimeters, which is 840 centimeters. Okay, so the actual trailer, okay, the length will be 840 centimeters in real life, but on paper they've scaled it down such that even though it is a smaller drawing, each 1 centimeter is 120 centimeters. Okay, I hope you understand what I mean. Another example here, using the scale 1 centimeter to 35 centimeters, draw a rectangle of 105 centimeter length and 70 centimeter width. So here again, if we look at this diagram, okay, we've been told to do 105 centimeter length, okay, and our scale is 1 centimeter to 35 centimeters. So if we divide 35 by 105, we get 3 centimeter length. Okay, so it means our rectangle 3 centimeters, the length is 105 centimeters. So on paper we'll be looking at 3 centimeters, but in real life it's 105 centimeters. And then we've been told that the width is 70 centimeters. So again, our scale is 1 centimeter to 35 centimeters. So 70 by 35 will be 2 centimeters. So 2 centimeters now is our width. Okay, so now we've reduced 105 centimeters by 70 centimeters to 3 centimeters and 2 centimeters. Okay, that is it could be a little plot, it could be anything, but we've reduced this large massive thing, and on paper we've reduced it to this so that we can be able, as we were drawing other things, or maybe it's a shape of a room, we can add other stuff, okay, and complete it. Okay, I hope I'm making sense. Another example here, using a scale of 1 centimeter to 10 kilometers, draw a triangle with base 55 kilometers and height 30 kilometers. So here now, okay, I'm quickly going to show you. Okay, these diagrams, I've checked them, I've drawn it to scale. So I'm quickly going to show you with a ruler, okay, how it is. Okay, so if you look at it carefully, okay, just give me a few minutes, let me find the ruler. Okay, I pack my things back. Let me just find the ruler and I'll show you. Okay, so here is the ruler. Okay, here is the ruler. So if you look at it carefully, there Okay, if you look at it carefully there, okay, 3 centimeters here. Let's look at it. There you can see 3 centimeters here. There, okay, that is 3 centimeters length. And then you can also see here 2 centimeters. Okay, so I've used the ruler. It's the centimeters here. So I've used the ruler to draw a rectangle to scale. Okay, this is to scale. There. So if you have a look at the ruler here is in centimeters. Okay. Now, using a scale of 1 centimeter to 10 kilometers, draw a rectangle with base 55 centimeters. So 1 centimeter to 10 kilometers. So 55 kilometers divided by 10 will be 5.5 centimeters. Okay, and a height. Okay, the height is not the slanted height, it's a perpendicular height of 30 kilometers. So 30 kilometers here divided by 10 is 3. So again, using the ruler, okay, my base here, okay, here, let's look at it again. Okay, I want 5.5, so from 0 on one end all the way, you can see 5. No, let me do it properly. 0, so you can see 5 there. Okay, 5 and 5.5. Okay, 5.5 there. Yeah, there. And then 3 centimeters, which I drew it right in the middle to get my perpendicular height. So 3 centimeters here, which you can see from 0 to 3. Okay, so I did it exactly in the middle. So I drew from one end to the top here and from the other end to the top. So that's my triangle. Okay, so this diagram now is to scale. Unlike the other ones I've been drawing, I've just been drawing using just drawing with a ruler. Okay, now let's look at the fourth diagram, which is a cuboid, which at times is easy to draw. So here, okay, I've been asked, maybe a company wants to decorate and they want a fish tank in the office. So they've asked somebody to go and look for fish tank. And then the scale they gave is 1 centimeter to 45 centimeters. Okay. And then they've asked them to find a cuboid fish tank. Okay, sorry, length of 315 centimeters, width of 166.5 centimeters, and 130.5 height. Okay, so now we need to find what we're actually looking for. Okay, so if 1 centimeter equals 45 centimeters in real life, okay, we want a length of 315. So if we divide 315 centimeters over 45 centimeters, we get 7 centimeters. Okay, so that is what we have at the minute. Now, if we divide 166.5, okay, so in real life, we are looking for 315 centimeters, but I'm going to draw, okay, I've been asked to draw, to scale. Now, the width is 166.5 centimeters. So when I divide by 45 centimeters, I get 3.7 centimeters. If I round this to the nearest whole number, it will be 4. Okay. Now, the height, 1 centimeter to 45 centimeters. So now, I want in real life 130.5 centimeters, okay, which is 2.9 centimeters. So this one also, if I round it off in real life, I'll get about 3 meters. So I've been asked to draw this to scale. So if I go to the shop, even though I have the measurement, I might not get this measurement accurately, but I might be able to use the measurement I've been given to purchase what I've been asked to do. But here, I need to draw it to scale on paper, maybe for an exam or maybe for my boss. So I've seen that the length should be 7 meters. So as you can see here, first of all, I try to draw the length and the width. So here, look. So 7 centimeters. So after doing my calculation, I realized that I need a length from 0 there to 7. Okay, assuming in the end I got 6.9 or 7.1 or 7.2, also because at times drawing to scale is a bit tricky. So that is exactly 7 here. Okay, that is the length. Now the width, we found it out to be 3.7. So let's see what we have here. Okay, so from here to there, if you can see there's 0. Okay, so I'm putting the ruler properly. So if you can see there, that is my 0, and that is about 3.5. So 3.7 is somewhere here. So I've got the length and I've got the width. Now my height is about 3.9. So the height here now, I need to find equal height. So if I do 3, or in the end I end up getting 3.1, it's still okay. Okay, so this is nearly 3.8. Okay, or 3.9. So You can see from here all the way to here, okay, which is about 3.8, or yeah, the height, okay. And there's another, no, it's 2 points, so there's another height here. Let's check. Yeah. So this height here is about yeah, about 3. There you can see it's 3, and we want 2.9. So look at it, we are nearly there. So we got the 3, you see. So even though we wanted 2.9, we've got around about 3. Okay, look at it there, the height 3, and it's the same as that. So we've managed to shrink our fish tank, which should be 315 centimeters length, 166.5 centimeter width, and 130.5 centimeter height, with using this scale. And that is how the fish tank looks, okay, on paper. So assuming I went to the shop and I got 7 centimeters, and then maybe 4 centimeters, or 4.1, or maybe in a catalog, or 2.9 or 3.1, in that range, or even 2.8, I can order that, okay, because maybe the space that we have can only take in these regions, okay. So these are how we use scale to we use it in real life, okay. So if I draw a diagram and I say this is not to scale, it means I haven't put any scale on it, okay. I've shown you how to put scale on your graph paper, yeah, but today we just want to look at what it means to get diagrams in shape and how they are useful in real life, okay. Thank you very much for watching today's video, and I'll see you in the next.